Astronomers have now unveiled the
first images of a giant black hole,
Sagittarius A star.
They say they've never seen anything like
We
it.
don't know what is inside a black hole.
The heart of the Milky Way Galaxy.
The universe keeps reminding us how little we know it.
What if the Milky Way, the vast, beautiful spiral we call home, is already showing signs of breaking down? What if the same colossal force that once helped shape our galaxy is now quietly preparing to tear it apart? Because deep in the heart of the Milky Way, near the monstrous black hole known as Sagittarius A, astronomers have just discovered something they weren't expecting: enormous radio jets. Gigantic streams of charged particles that shouldn't even exist, according to everything we thought we knew about our galaxy. And these jets aren't just random bursts of energy. They might be the first signs of a long, slow instability, the kind that could, over millions of years, change the Milky Way forever. The calm before the cosmic storm. For centuries, humanity believed our galaxy was a stable, peaceful spiral of hundreds of billions of stars, drifting gracefully through the cosmos. The Milky Way was thought to be mature, balanced, and quiet compared to the raging, luminous galaxies we often see in deep space images. But that calm might have been deceptive. At the center of our galaxy lies Sagittarius A, a supermassive black hole roughly 4 million times the mass of our Sun. For decades, scientists believed it was relatively dormant, feeding only occasionally on the stray gas clouds that drift too close. Unlike other galaxies with active violent cores, our black hole seemed peaceful. Until now. Because when radio astronomers began peering deeper, using telescopes capable of detecting faint emissions invisible to the human eye, they saw something stretching from the heart of the Milky Way. Two vast structures, thousands of light years tall, blasting outward like cosmic flamethrowers. Radio jets, invisible to ordinary light, but screaming in the radio spectrum. The discovery that changed everything. The discovery came from a combination of data sets, including the Meerkat Radio Telescope in South Africa and NASA's Fermi Gamma Ray Space Telescope. When researchers compared observations, they noticed something strange: enormous lobes of radio-emitting gas rising north and south from the galactic plane, like the galaxy itself had exhaled twin jets of plasma. These structures span 25,000 light-years. That's roughly 1/4 the diameter of the entire Milky Way. To put that into perspective, if light took 1 second to travel from Earth to the Moon, it would take 25,000 years to reach the edge of one of these jets. Scientists call them Fermi bubbles, and they are unlike anything we've seen in our galaxy before. They appear to be remnants of an ancient outburst, an energetic explosion triggered by Sagittarius A millions of years ago. But what's more disturbing is the possibility that they might not be relics at all. They might be reactivating. When the black hole wakes up. Supermassive black holes like Sagittarius A are not always dormant. Across the universe, we've seen countless examples of what happens when one wakes up. When gas, dust, or even stars fall into its gravitational grip. The material heats up and spins into an accretion disk, a glowing violent ring that can outshine the rest of the galaxy. As this process unfolds, the black hole can unleash titanic jets, narrow beams of plasma that shoot out from its poles at nearly the speed of light. These jets stretch for tens or even hundreds of thousands of light years, reshaping their host galaxies in the process. Galaxies like M87 or Centaurus A show this in vivid detail. Their jets tear through interstellar gas, ignite new star formation in some regions, and extinguish it in others. In short, they rewrite the structure of entire galaxies. Now, imagine if Sagittarius A, our own central black hole, began doing the same thing. That's the scenario some astronomers now believe might be starting. The evidence builds. In late 2024, researchers from the University of Cape Town and the Max Planck Institute published new findings suggesting that the radio jets from the Milky Way's core are not ancient fossils. Instead, they appear to be active, faintly powered, as if the black hole has begun to stir again after a long sleep. The evidence? The polarization of the radio waves. When scientists studied the jets, they found that the electromagnetic fields inside them were highly organized, not random, like you'd expect from a fading remnant. This pattern indicates motion-flowing plasma, twisting magnetic fields, and ongoing acceleration. In other words, something down there is still pushing energy outward. Sagittarius A is becoming active again. In that case, we're witnessing the very early stages of a cosmic awakening that could transform the Milky Way's structure, radiation balance, and long-term stability. What happens when a galaxy turns violent? An active galactic nucleus, or AGN, is one of the most powerful phenomena in the universe. When the central black hole ignites, it consumes surrounding material and releases immense amounts of energy, sometimes more than all the galaxy's stars combined. These eruptions drive shockwaves through interstellar space. Gas clouds collapse or disperse. Star formation spikes and then halts. The galaxy's spiral arms distort. Over eons, this can even change the shape of the galaxy entirely from a thin spiral into a bloated elliptical form. Now, imagine our peaceful Milky Way undergoing that transformation. It wouldn't happen overnight, of course. These processes take millions, even billions of years. But the key is this: instability has begun. The Milky Way may not be the eternal, calm island of stars we thought it was. It may be entering a phase of cosmic volatility, one that could last for millions of years, reshaping its destiny forever. A black hole that breathes. To understand what might come next, scientists often describe supermassive black holes as breathing entities. They inhale gas and dust, flare up with activity, and then fall dormant again, a cosmic inhale and exhale cycle that can repeat for eons. Sagittarius A seems to be in one of those cycles now. A few thousand years ago, something massive might have fallen into it, perhaps a gas cloud or a star cluster, triggering a brief but violent outburst. The newly discovered jets could be the aftermath of that feeding frenzy. But there's growing evidence that more material is on the way. In 2023, astronomers detected a massive gas cloud known as G2, moving dangerously close to the black hole's event horizon. Predictions suggest that over time, pieces of that cloud will spiral inward, potentially feeding Sagittarius A again. If that happens, the energy output could multiply by a factor of thousands. And once that chain reaction begins, it could sustain new radio jets, powerful enough to light up the entire galactic core again. The anomaly no one expected. Here's where it gets even stranger. While studying these radio jets, astronomers also found something they couldn't explain: a magnetic void surrounding parts of the emission zones. In certain regions, the normal galactic magnetic field appears disrupted, weakened, or twisted out of alignment. It's as if the black hole's magnetic field has started to rewire the galactic core. This kind of disruption isn't normal. In stable galaxies, the magnetic fields run smoothly along the spiral arms. But in the Milky Way, there's now evidence of chaotic fluctuations, localized distortions that could affect the behavior of gas clouds, star formation, and even cosmic ray movement. If this continues to evolve, the central region of our galaxy could become magnetically unstable, a condition that, over astronomical timescales, may ripple outward, affecting the balance of the entire disk. A small, slow-motion collapse, one we wouldn't notice in our lifetimes, but which could eventually alter the Milky Way's shape and stability beyond recognition. Our galaxy is already changing. Some astronomers think the first signs of this shift are already visible. When the Gaia mission mapped the Milky Way's stars with unprecedented precision, it discovered that the galaxy's disk isn't flat. It's warped, twisted like a bent vinyl record. For years, this warp was blamed on interactions with neighboring galaxies. The Magellanic Clouds or the Sagittarius Dwarf Galaxy. But newer simulations show that those external forces alone can't account for the extent of the distortion. One hypothesis suggests internal forces, specifically gravitational disturbances from the central region, might be contributing. In other words, the Milky Way's own black hole could be indirectly twisting the structure of its spiral arms. If that's true, the newly discovered jets and magnetic anomalies might not just be isolated phenomena. They could be symptoms of a deeper, system-wide instability, one that's already bending the very shape of our home galaxy. The domino effect. Let's imagine this instability playing out over time. As Sagittarius A continues to feed, its jets grow stronger. The galactic magnetic field becomes increasingly chaotic. Gas clouds, sensitive to these magnetic and gravitational shifts, start moving erratically. Some collapse into bursts of new star formation. Others dissipate, starving certain regions of raw material. Meanwhile, radiation from the black hole's core begins to intensify. It floods the galactic center, stripping electrons from atoms, altering chemical balances, and creating massive dead zones where new stars can no longer form. The Milky Way's spiral arms, delicate, organized structures shaped by gravity and motion, could start to lose cohesion. Over millions of years, the disk might puff up, losing its elegant spiral form and evolving into a more spherical, elliptical shape. This isn't speculation. We've seen it happen. Other galaxies that once resembled the Milky Way have gone through similar transformations after their black holes awakened. It's a process astronomers call galactic quenching, the slow death of star formation, triggered by the fury of a central black hole. The countdown to collision. And then there's the future no one can avoid, the Andromeda Galaxy. In roughly 4 billion years, our Milky Way and Andromeda are destined to collide. This event has been known for years, but new research suggests that the instability in our galaxy's core could dramatically influence how that merger unfolds. If Sagittarius A becomes active again, its jets and radiation could alter the distribution of gas long before Andromeda arrives. The collision, instead of forming a calm elliptical galaxy, might ignite into something far more chaotic. A supermassive merger of two active black holes, spewing radiation across millions of light years. When the two black holes finally coalesce, they'll release gravitational waves powerful enough to ripple across the universe. Entire star systems, including possibly our own, would be flung into intergalactic space. So yes, the Milky Way's fate was already dramatic, but this new instability adds a dangerous twist. Our galaxy might enter that collision already unbalanced. The chain reaction we can't stop. Every new piece of data hints at a sobering truth. Galaxies are far less stable than we once imagined. They live, breathe, and eventually decay, shaped by the same forces that gave them life. For the Milky Way, that cycle seems to be accelerating. Sagittarius A's quiet years might be ending. The radio jets show that it's still incapable of immense power. The magnetic anomalies suggest the galaxy's inner regions are destabilizing, and the warping of the disk might be the first sign that these internal changes are already propagating outward. None of this means Earth is in imminent danger. Even if Sagittarius A erupted tomorrow, the radiation wouldn't destroy us. The galaxy is far too great. But the galaxy itself may be entering a new evolutionary phase that will reshape it forever. A slow-motion transformation that could mark the beginning of the Milky Way's end as we know it. Rewriting our place in the cosmos. Here's the unsettling part. The Milky Way has long been our reference point for what a normal galaxy looks like. It's the baseline, the standard model. But what happens when the standard model turns out to be unstable? It means everything we thought we knew about galactic life cycles might need revision. Perhaps most spiral galaxies go through dormant and active phases more often than we realized. Perhaps our galaxy's calm was only temporary, a lull between violent outbursts. If so, then what we're witnessing today ain't radio jets, magnetic distortions, and growing asymmetry. May not be an anomaly at all. It may be the natural heartbeat of a living galaxy. The hidden pattern. In recent years, astronomers have begun mapping galaxies not just as static shapes, but as evolving systems. When viewed this way, patterns emerge as waves of instability that ripple outward from galactic centers every few 100 million years. These waves can synchronize with gravitational interactions, like tides within the galaxy. The result is a self-sustaining cycle. The black hole feeds, the jets ignite, magnetic chaos spreads, the galaxy reshapes, and then it all quiets down until the next flare-up begins. Some simulations now suggest the Milky Way might be right at the beginning of one of these cycles, a long, slow process that could define the next 100 million years of its history. And while we'll never see the full story play out, we might be witnessing the first chapter right now. A universe that never sleeps. If there's a reason in all this, it's that the universe is never truly still. Even the most serene night sky hides unimaginable turbulence. Galaxies twist, collide, and transform. Black holes flicker between silence and fury. The cosmos itself is in constant motion. The Milky Way's frightening future isn't an immediate apocalypse. It's a reminder that cosmic stability is an illusion. The forces that made our home possible are the same ones that will, eventually, unmake it. Every star you see tonight, every nebula, every cluster, they all owe their existence to ancient cycles of destruction and rebirth. Sagittarius A is simply the next participant in that endless dance. The final quiet thought. So what should we feel, knowing that our galaxy's future may already be unraveling? Fear? Awe? Maybe both. On one hand, the instability in our galaxy's heart reminds us how fragile cosmic order truly is. On the other hand, it shows us that even in the face of such vast, uncontrollable forces, life, including our own, found a way to exist, however briefly, in the quiet space between storms. The Milky Way's radio jets are a message from the past, and a warning for the future. Nothing in the universe stays calm forever. The cosmic clock is still ticking. And somewhere, deep in the heart of the galaxy, the black hole that made us possible may already be preparing for its next act. Stay blessed and stay curious.